All right, we're looking at inverse functions today. So here at the top, if you remember back when we first looked at functions, we had the vertical line test to determine if a function was a function or a relation was a function. Now to figure out if functions are one-to-one, we have what we call the horizontal line test. All right, so right here, horizontal line test. So it says a function is one-to-one if every horizontal line that intersects the graph of the function at most once. Right? So if a function passes the horizontal line test, then that makes that function one-to-one as well. So if we look here at this first one, all right, we want to determine if this function is one-to-one by graphing it and using the horizontal line test. Let's see. We need to draw some axes here. So this is basically saying like half of a circle that has a radius of 7. Right? So it's going to be looking something like this. So then if we think about trying to draw a horizontal line through that function, we're going to see that it's going to hit that function at 2 points at the same time. So this would be no, it is not one-to-one because it does not pass the horizontal line test. All right, so it is not one-to-one. So that's basically it. Look at a function and look at its graph, decide if it's one-to-one by deciding if it passes that horizontal line test. All right, so the main part of what we're looking at here is going to be looking at inverse functions, right, and how to find those inverses of different functions and how to determine if two functions are inverses of one another. So it says let f be one-to-one, and then g is the inverse of f. It's denoted by f of -1. It says do not confuse the -1 with a negative exponent. This symbol does not represent 1 over f of x. So that f of -1 is not talking about exponents. We're talking about the inverse of that function. So it says important facts. If f is one-to-one, then f -1, which is the inverse, exists. The domain of f is the range of f -1, and the range of f is the domain of f -1. So basically, domain of the function is the range of the inverse, and the range of the function is the domain of the inverse. So they flip-flop there. If the point AB lies on the graph of f, then the point BA lies on the graph of f -1. All right, and this shows that they are reflections across the line y equals x. And then it says to find the equation for the inverse. Replace f of x with y, interchange x and y, and solve for y. This gives you the inverse of that function. All right, so how do we determine if two functions are inverses of one another, like we have here in example 2? Well, we do that by doing the composition. So we've looked at compositions before, but we're going to do f of g of x, and we're going to see, does that equal x? And then we're also going to do g of f of x and see if that equals x. If that is the case, then we will know that these are inverses of one another. So starting out with f of g, this means that function g goes into function f. So f of g first. Function g, right here, is going to go in place of x in f. And we're going to look to see if we simplify this, does it come out to be equal to x? So let's see, we distribute That's going to be x. That's going to be 10. And then we're going to have plus 5. So that's going to be x minus 5. So right there, that kind of indicates to us that no, these are not going to be inverses of one another. We can just check to make sure that the other way does not work either. So in this case, we're taking function f, and it's going to go in place of x in function g. So we distribute. That's going to be x plus 5/2 minus 5, which again, that is not going to, because these are not going to cancel each other out. So again, this is not going to be equal to x. So these are not going to be inverses of one another. Right. Here we have another one that we can look at to decide if these are inverses of one another. All right, so again, same concept. We got to do f of g, and we have to do g of f. And we have to see if they end up simplifying down to just an x. So f of g to start out with means we're going to take function g and we're going to plug it in right there, and we're going to see if we simplify it, do we end up with just an x. All right, so for dividing by that whole thing, we can do keep, change, flip. So keep the top, change it to multiplication, and then flip the one on the bottom. So that's what I'm doing here with that complex fraction there. So those ones end up canceling out. That leaves us with 4 minus x, which then gives us 4 minus 4 plus x. 4's cancel out, leaving with just x, which is what we wanted. So we're off to the right start. We'll do the same thing, go the opposite direction. We're going to take function f, and we're going to put it in here for x. So let's see, doing some simplifying here. It's going to be 4 minus 4 plus 1 over x. 4's are going to cancel. We're going to get 1 over x. Again, we can do keep, change, flip, which then the ones cancel, leaving us with just x, which is what we wanted. So yes, they are inverses. All right, so in each case, like I said, you're just doing the composition of those functions, all right, and seeing if they are equal to x. All right, number 3, it says use the figure to graph the inverse of the function. Please show your table for both functions. So if we remember back over here, we said that this part about if the point AB lies on the graph, then BA lies on the inverse of it. That's going to be the important part here with trying to find the inverse of this graph that we're looking at here in example number 3, is we are going to list out the, let's get the pen, not the highlighter, there we go. We're going to list out the points that are on function f here. So f is at -3, -2, -1, 0, and then 4, 2. So then the inverse of that, we said, is just going to be each of those points flipped. So the x and y flip. So you're going to have -2, -3, 0, -1, and 2, 4. So just flipping each of those ordered pairs gives you the inverse of that function. All right, and so let's see if we graph those. -2, -3 right here, 0, -1, and then 2, 4 right there. Right, and there is that function. Right, so if you're just finding the inverse of sets of ordered pairs, just flip their x and y coordinates and you get that inverse. All right, these steps were mentioned earlier, but we'll go back through them. So if we have a function, right, so not a set of ordered pairs, but a function here, and we want to figure out the inverse of it. So it says to start out by changing f of x to y, switch our x and y, solve for y, and then change the y to f-1 of x. So let's go through those steps. So first one is change f of x to y. So it's going to be y equals 4x minus 7. Then step 2 says to switch our x and y. And so you can see there, switching the x and the y. Step 3 is going to be taking that equation that we have there in step 2, and we're going to start solving this for y. So I'm going to go +7. And then divide everything by 4. And this is like a 1 in front of that x. So that's going to be 1/4 x plus 7/4. And then lastly, step 4 said to replace the y with f-1 of x. So f-1 of x is equal to 1/4 x plus 7/4. So there's our inverse, 1/4 x plus 7/4. Okay, and then they ask us to give the domain and the range of each of these. So we'll do domain of f of x and the range of f of x. And then we'll do the inverse as well. All right. Both of these are just linear equations. All right. So, I mean, somehow this first equation is going to look something like this when we graph it. All right. It's just going to be a slanted line. So if I'm thinking about domain of that x values from left to right, it's going to continue to go to the left forever. It's going to continue to go to the right forever. So that's going to make the domain -infinity to infinity. With that being the case, then we said that that would then be the range of our inverse. So the range here is going to be -infinity to infinity. All right, that's of the inverse. If I look at this graph, and again, like I said, this is just some linear equation here, slanted line. If I think about bottom to top, talking about the y values, it continues to go down forever, which is towards -infinity, and it continues to go up forever, which is towards infinity. So the range here is also going to be -infinity to infinity, which is then also going to make the domain, all right, the domain of the inverse is going to be that as well. All right, for our next one here, again, the same 4 steps, all right, same 4 steps to find that inverse. All right, we're going to start out by replacing f of x with y. Then we're going to switch that x and y. And then we're going to start solving that equation from step 2 for y. Starting that process out by squaring both sides to get rid of that square root. So it's going to give us x squared equals y plus 5. and then we'll go minus 5. And so we're going to end up with x squared minus 5 equals y. And then lastly, step 4 is to replace that y with f negative 1 of x. That's our inverse function notation. All right, so there's our inverse. Now we need the domain and range of the function itself, and we need the domain and range of the inverse. All right, so looking at the first part there, okay, the first part, it tells us, all right, it tells us right here what the domain is of that regular function. It tells us that x must be greater than or equal to negative 5. So if I want to write that in inverse notation, all right, that's going to be bracket negative 5 to infinity. All right, with that being said, all right, then that makes the range of the inverse is going to be negative 5 to infinity. Then to figure out the range, all right, if you were to graph this function, all right, thinking about this negative 5, which is the x coordinate of the vertex, all right, if we plug that in, all right, if we plug in negative 5 into that equation, then that's going to give us, all right, if I plug that in, that's going to be to get the square root of 0, which is 0. So the y coordinate there of that vertex, which is where this function starts, since it's a square root, that tells us that the range, all right, is going to start there. And when you graph this one, if you plug that into your calculator, you would see it would look something like this, all right? So that range is going to start there at 0, which is the y coordinate of that vertex, and then it's going to continue going up forever, which is to infinity. So then that means that the domain of the inverse is going to be that same as the range of the function itself. All right, there's another one here, example C. I'm going to leave that one for you to try on your own. Of course, you can always go to the answer key in Moodle and check to see if you got it correct. And then one more here, and we'll go through this one together as well. So let's start out by finding that inverse. So we're going to replace that, in this case is g of x, replace that g of x with a y. And then we're going to switch our x's and y's. So that's what I did there. And then now we're going to take that equation from step 2. We're going to start trying to solve it for y. And we're going to do that by multiplying both sides by y minus 3. So we're going to end up with x times y minus 3 equals y plus 1. And I'm going to distribute that x, give me xy minus 3x equals y plus 1. All right, now ultimately I need to get those y's together because we got to be able to eventually solve for y by itself. So let's start out by moving just that 3x to the other side. And then I'm going to move the y over here with the other y. So we're going to get xy minus y equals 3x plus 1. Right, and then to pull that y out, so that y is by itself, I'm factoring it out of these two things that are on the left-hand side. Those two things on the left-hand side have a y in common, so I can factor it out. That's going to leave an x, and then y divided by y is just 1. And then to get that y by itself, we'll do divided by x minus 1. So we end up with y equals 3x plus 1 over x minus 1, which is going to be our inverse in step 4. When we replace that y with f negative 1 of x, or actually it was g in this case, let's get it right. This is g negative 1 of x, because we were talking about a function g here. So there is our inverse. And then we need the domain and range of both. Again, these were g's. Let's get that right. So domain of g. And then inverse as well. All right, so it told us up here in the beginning, what x could not equal. So that's going to be part of our domain here, right here. It said x could not be equal to 3. So our domain then is going to be negative infinity to 3 union 3 to infinity. Okay, so then that's also going to make that the range of the inverse. And then to get the range here, right, to get the range of that this function. This is a rational function, all right? And so in this particular rational function, we need to figure out basically where is the horizontal asymptote, all right? That's what we're looking at here. And to be able to do that, then we are going to compare the coefficient or the exponents and the coefficients of the numerator and denominator here. So if I look at the exponent here in the numerator, that's a 1, and the exponent in the denominator is also 1. So that means that the top exponent is equal to the bottom exponent. And if that is the case, then we say that the horizontal asymptote is y equals a over c, where a and c stand for the coefficients of those x's. So in this case, both of those have a understood 1 in front of them, which makes this equal to 1. So this has a horizontal asymptote of y equals 1, which means that it gets really close to 1, but it's never actually going to equal 1 for those y values. So our range here is going to be from negative infinity to 1 union 1 to infinity, which then is also going to make the domain of the inverse, negative infinity to 1 union 1 to infinity. Right, so that completes these notes. Again, go back and try to do that third example on your own and check your answer with the answer key in Moodle.